Okay, so the second type of equation we're going to be taking a look at now is this type here. Last time in the first video we did that, and now we're moving on to this. Logarithmic equations, so equations that actually have logarithms in them, where the logarithms show up on both sides of the equation. So, like this example here, you should see logarithm on one side, you should see logarithm on the other side also. The steps you're going to go through here are not too bad. You will notice, though, that there's a little asterisk right here, and there's another little asterisk right here. I'm going to come back in a minute and talk about what that asterisk is about. That's saying something, but it's going to be a mystery at first. Okay, so here's how you begin. The first step of logarithm equations like this are to compress both sides into a single logarithm. So for us, the right-hand side is already a single logarithm. It's the left-hand side that needs some work. So on the left-hand side here, I have a logarithm minus another logarithm. The logarithm properties we learned a couple of sections ago tell us that when we make a single logarithm out of that, it'll be a log of a quotient. X plus 5 will be the numerator, x minus 4 will be the denominator. So that's your first step. Make each side of the equation into a single logarithm only. And then the second step is luckily really simple and kind of obvious. You cancel out the logarithms. Now you'll notice when I say cancel out here, and I did this in the first video when we were talking about exponential equations, I put quotes around that, because that's actually a sort of a sloppy bit of vocabulary. There's an actual technical thing going on here having to do with the one-to-one nature of the logarithms, but unless you're really curious about the underpinnings of mathematical theory, you probably don't really care about all those logical descriptions of what's really happening. The actual process involves making the logarithm no longer be written down, rewriting the equation so it looks like this. And with the logarithms eliminated from the equation, you should be able to finish this thing up really quickly and easily. So, from here on out, continue as normal. So let's see, what would normal be here? Well, I've got a denominator, so I would multiply that denominator up to the other side so that I won't have a fraction anymore. And then I'd have to distribute in the 3. And then I'm going to subtract x, and I'm going to add 12. And just like we had last time, that ends up giving us a fraction, 17 over 2. But this is the interesting and complicated thing about this. We aren't actually done at this point, and this is why we had the asterisk back in the beginning. Here's what's going on. You're going to have to think back to a few sections ago. Think back to when we were graphing logarithms. In particular, remember that logarithms have a very limited domain. You can only plug positive numbers into a logarithm. If you try to do a logarithm of 0, or if you try to do a logarithm of negative numbers, you get nonsense. You get no answer at all. The graph doesn't go there. And think about, in particular, this part of the equation here. If I take 17 over 2 and I plug it in here, since I'm subtracting 4, there's at least potentially a chance that maybe I might get a negative number. And then I'd be trying to do log of a negative, and we'd have a bad result happen. We'd have an impossible situation. So what this means is, and please don't panic, this is not the first time we've seen something like this. What this means is you must check your answers. That's what those little asterisks means. It means checking is not optional. And let's make this perfectly clear. If you're taking a test and you do not write down a check, if there's nothing written down showing that you checked your answer, the maximum you can get on that question is half credit. So do not take this lightly. I am dead serious that if there is a logarithm in the equation, there had better be something written down at the end of the problem where you check your answer. So let's talk about how to do that. The check down here is to take 17 over 2 and plug it back into the original equation. So I'm going through the original equation. Every place where there was an x, oops, I almost wrote plus. Every place where there was an x, I'm putting in 17 over 2 instead. And then, this part's good news, you don't have to do those logarithms by hand. Especially this one over here on the right, log base 12 of 13, that's going to be some nightmarishly ugly decimal. What you do at this point is you grab your calculator and use the calculator to work out these logarithms. So this stuff here can be all done on the calculator. And this here you can do on your calculator too. Don't forget that since the base is base 12 here, you're going to have to use the change of base formula that we learned in just the previous section. In 12.5, the change of base formula allows us to change the base to anything and then work that stuff out on the calculator. And when you do the work here and work out the answer on each side, they come out the same. So this is the correct answer. It does check. This subtraction here does not end up, it turns out, producing a negative number. 17 over 2 minus 4 is still positive, and everything here works out just fine. So, let me reiterate what the steps are here to make sure it's perfectly clear. Step 1, compress each side into a single logarithm. Step 2, cancel out the logarithms. Be careful. If some part of you is worried, what if the logarithms aren't the same? Like what if one's base 12 and the other's base 7? Don't worry about it. That will never happen. I've never actually seen any textbook ever that uses equations that have more than one base in the same problem. At least not until you get to upper division post-calculus mathematics. And then they come back and study that sort of thing. But for you, never going to happen. The bases will always match. Cancel out the logarithms, continue as normal, and then be absolutely certain that you actually check the answer. Go back to the original. Always plug into the original, not to something where you've already done some work. The good news is that checking can be done on the calculator, and that won't be too bad.